Canned goods for Friday.
Yeah, kind of like that robot.
See, but that. Okay. We're recording. Here we go. Cable supports a suspension bridge and it forms a parabola. The horizontal distance between the ends of the cables are 140 meters, so we have like bridge part here, here's the bridge part here. And then make sure it doesn't dip into the water below, everything's good. The midpoint of the cable is 14 meters below the end of the cable. So we know that this distance is 14. We need to make an equation that models this. The first thing that we're going to do to make this equation is decide how are we going to set up our axes. How are we going to set up our x-axis and our y-axis, because this doesn't have any of that. And wherever we decide to put that, it's going to change our equation. Most commonly in a situation like this, people like to make their x-axis and y-axis so that maybe your vertex is right at 0, 0, because that makes life a little bit easier. There was nothing in this that said the level, that the bottom of the bridge was a certain distance above the water, because then I might make the x-axis my water level. But whatever you choose, you need to choose something that makes sense given the situation. And so here, having our vertex right at 0, 0 seems to make sense. And if we have that and we need to make an equation, remember our equation looks like this, where P and Q are from the vertex, and A determines how wide or whether it goes up or down. Can you see by deciding to have our vertex at 0, 0, we already know what P and Q is. In fact, our equation with those zeros in there is just going to look like this, because P is equal to 0 and Q is equal to 0. So the only thing we have to find in order to make this an equation is the value of A. Do you remember in a previous example how we found A when we didn't know it? If we could plug in a point, right? You plug in something for x and something for y, then the only thing you wouldn't know is A, and you could solve for A. Now we have to look back at our picture and figure out, is there another point on the parabola that we could label? We already labeled our vertex as 0, 0. Right there or right here. Okay. Would you, since that goes up 14, you know the y-coordinate is 14, right? For both of those. What would the x-coordinate be for these? Minus 70 and 70. How do we get those numbers? Well, if there's 140 between them, and because parabolas are symmetrical, half of the 140 has to be on this side, and half of the 140 has to be on that side. So then we know we've got a point. One could be negative 70, 40, and the other could be 70, 40. So now I can plug in a point. I can say I know that when y is 14, x is 70. We're going to get some big numbers here, because we're going to get 14 equals 4900 A once you square 70. And so A is equal to 14 over 4900, which I'm not sure. Do they give a decimal? Or do they just reduce it to a fraction? They reduce it to a fraction. Now, if you take 4900 and you divide it by 7 and then divide it by 2, this does reduce to 1 over 350. And so now we can say we figured out the value of a. We can write our equation y is equal to 1 over 350 x squared. And I think that makes the most sense to have the vertex there. In the answer key, they've given 3 different possibilities because I think for one of them, they decided to have the x and y axes over here. Another one, they decided, what happens if I have my x and y axes over here? I hope you can see that this is the simplest, because then we know our vertex the easiest way right away. Question you can do for this one is number 11.